Hi everybody, today we're looking at our second type of differential equations. So we've seen separable differential equations, now we're looking at homogeneous differential equations. And a homogeneous differential equation is a differential equation which can be expressed as a function of y over x. In other words, it would be a function, I'll just change my pen, so it would be something like dy on dx is equal to some function of y over x. Now, why is it called homogeneous? Well, if we were to multiply both x and y by the same constant, we'd still have the same differential equation. So, in other words, if I had f of ky on kx, well, the k's would cancel and that would just be equal to f of y on x. And so, those two differential equations would be the same. Hence, homogeneous, meaning the same. So, multiplying x and y by the same constant won't change the differential equation, which is why it's called homogeneous. Now, the most important thing is to understand the process on how we differentiate these. So, first of all, I want to get it into the form as a function of y on x. So I'm going to move everything to the right hand side. So I'm going to start with x dy dx is equal to x squared sine x plus y. And then I'm going to divide through by x. So it'll be x squared sine x on over x plus y on x. And so then the x's cancel there and I get dy dx is equal to x sine x plus y on x. And so this is a function in terms of x and y on x. And so it's homogeneous. Now, in being able to solve this, what we want to do is we want to substitute v for y on x. Now, if I do that though, I've got to make sure that I deal with the fact that this here is also in terms of y, it's dy on dx. And so I need to change that dy dx to dv dx. So if I think about this, we know that v is equal to y on x. And so we can say that vx is equal to y. Now if I differentiate both sides with respect to x, I'm going to have to use the chain rule on this, because that's a function v times the function x. So it'll be the derivative of v, which is dv with respect to x, so it'll be dv dx times by x plus v times by the derivative of x, which is 1. And that will equal dy dx. So we've got this equation that dy dx is equal to dv dx x plus v. So when I substitute v for y on x, I also substitute this expression here for dy dx. So that gives me dv dx x plus v is equal to x sine x plus v. Now, it happens in this case that the v's actually cancel. And we get that dv dx times x is equal to x sine x. So dv dx x is equal to x sine x. So dividing both sides by x will give me dv dx is equal to x sine x on x. X's cancel. And so then dv dx, well, if I integrate both sides, I'll get v on the left-hand side, and the integral of sine x with respect to x is minus cos x. So v is equal to minus cos x plus c. But we wanted y. We wanted the solution to this differential equation, which means we want y. And so if v is equal to minus cos x plus c, then that means v was y on x, that means y on x is equal to minus cos x plus c. So y is equal to minus x cos x plus cx. Don't change that to a c1 because now we're multiplying it by a variable, and so it's cx. You can only change the constant to a different arbitrary constant if you're multiplying by a number. Here we're multiplying by x. And if we were given a point on our new curve, then as a result we would be able to find what c is. Okay, alright, and so that's the solution to this equation. Now this is a past exam question, so I thought it'd be useful to go through it, to look at how to do it, and also to have a look at the mark scheme, so we'll see what they're giving marks for. So, got to use the substitution v equals yx to show that 2x dv dx is equal to v take 1 squared. Okay, so basically we have to substitute in v for y on x and get it in terms of x and v. Okay, so 2x squared dy dx is equal to x squared plus y squared. First thing I'll do is I'll divide everything by x squared. So I have 2 dy dx is equal to x squared on x squared plus y squared on x squared. That cancels down to 1, so I have 2 dy dx is equal to 1 plus y on x all squared. Now, you don't have to re-demonstrate or reprove the fact that dy dx is equal to dv dx x plus v. You don't have to prove that every time. You can just use it. And because we're always using v equals y on x, it'll always be the same. Now in this case I need to have a 2 at the front, so it'll be 2 dv dx x plus v is equal to 1 plus v squared. Okay. Now what did we have to show? We had to show, so it'll be 2 dv dx times x plus 2v is equal to 1 plus v squared. So rearranging that into the form we want, so it's 2x dv dx. Yep, that's the first term, just rearrange so x is in front of the derivative. And this will be v squared, move the 2v to the other side, take 2v plus 1. And that factorizes to v take 1 all squared. So we've shown what they want. We've shown the first bit. I'm going to need some more space. We'll look at the mark scheme later. And then they want us to find the solution and show that it's equal to that. Okay, alright, so solving this. Well, we've got a function of v and a function of x. So this is separable. So if I bring the function of x to the right hand side and the function of v to the left hand side, I'll have 1 on v minus 1 squared on the left hand side, dv dx, is equal to 1 on 2x. And then I integrate both sides with respect to x. Now, so I'm doing the integral of 1 on v take 1 all squared dv is the integral of 1 on 2x dx. 1 on 2x is fine. 1 on v take 1 squared makes us think a bit longer. So, okay, so 1 on v squared is v minus 1 to the power of minus 2 dv. So it's a linear function to a power, so we can integrate that. On the left hand side we have 1 on 2x, so it's a linear function inside the function 1 on and 1 on a function. So that's ln. So it's ln of the modulus of 2x divided by the derivative of the inside, which is 2, plus c. Now if we just scroll back up for a second, we're told this, x is greater than 0. So I don't actually need modular signs around 2x, because I know that 2x is greater than 0, so I can just write it like that. I'll just write x greater than 0. Now integrating v take 1 to the power of minus 2, I add 1 to the power, so it's v minus 1 to the power of minus 1, divide by the new power of minus 1, and divide by the derivative of v take 1, which is with respect to v, which is just 1. So it's ln 2x on 2 plus c. Okay, so I have negative v take 1 to the power of minus 1 is ln 2x on 2 plus c. And let's have a look, what are they asking us to try and show? So if I'm going to say out here is what we're trying to show, so if I'm going to try and show that, I'm going to have to substitute y on x for v. Not sure I want to do that yet though. So I've got minus 1 on v minus 1 is equal to a half ln 2x plus c. Okay, so what I'll do is I'll bring all of this down into the denominator there, and I'll bring v take 1 up to the numerator on the other side. So I have minus 1 all over a half ln 2x plus c is equal to v take 1. And then, hang on, that should be ln 2x. Now, what I'll do is I'll take a half out of the c and call that c1. And the reason I'll do that is I'll bring it out as a half multiplied by ln 2x plus c1 equals v take 1. Now the reason I do that is so I can then say that this 1 on a half is just 2 in the numerator. So let's keep going. And I'll bring the negative over to the other side. So when I bring the negative over to the other side, I'll have 1 take v. 2 will be up in the numerator of this one, and I'll have ln 2x plus c, 1. Now I'm going to put y on x back in, so it'll be 2 on ln 2x plus c1 is equal to 1 take y on x. Let's multiply everything by x to get rid of it in the denominator there. So on this side I'll have 2x on ln 2x plus c1 is equal to x take y. So move the x to the other side. So I'll have 2x ln 2x plus c1 minus x is equal to minus y. And so then multiplying both sides by minus 1 will give me x take 2x ln 2x plus c1 is equal to y. And that's what we were trying to get. The fact that I've got a c1, hang on, it's not quite what we were going to get, what we wanted to get. So they've got an ln x and I've got an ln 2x. But one of the tricky things to notice with this one, it is actually the same thing. So I have x take 2x. ln of 2x I can write as ln x plus ln 2 plus c1 is equal to y. And then the ln 2 and the c1 can just be absorbed into a single arbitrary constant, which we say is ln x plus c2. And so it is actually the same thing as what we had. Okay, alright, and then find the value of c, that given that when y is 2, x is 1. So I substitute, so 1 take 2 on ln 1 plus c2 is equal to 2. ln 1 is 0. So it'll just be 1 take 2 on c2 equals 2. Move the 1 to the other side, so we get negative 2 on c2 is equal to 1. So negative 2 is equal to c2. So c2 is equal to negative 2. And that's the value. Okay, alright. So let's have a look at the mark scheme. So 1 mark for putting this in for dy dx, and So they went a slightly different way. So when they had y squared, because y is equal to vx, they've said that y squared is equal to v squared x squared. But at the end of the day, it's the same thing. And so really 1 mark for doing the substitution. So I'll just scroll back up to the question. So it says using this substitution, and we have used that substitution. We've used it in a slightly different way, so I don't think they'd take any marks off for that. So y squared is equal to v squared x squared is what they've done there, but we've just said y is equal to, or v is equal to y on x. And so then they've gone through and divided x squared by everything, which is turned that into that one, and x squared there into 1, and this term into v squared, and they're divided through by 2 as well. And then they've from there moved v onto the other side to get v take 1 all squared. But they've also brought this 2 up to this term as well. So probably not super clear exactly what they've done, but it does work out to be the same. And then they've integrated both sides. So they had the 2 out the front as a constant, which could have been another way of dealing with 2. And then minus 2, so they've integrated v take 1 squared and 1 on x to ln x plus c. They've then put y on x back in and rearranged it to get what they need. So it says for other approaches it will marks as follows. So m1 for separation of variables, so we did that. So we get our m1. A1 for correct integration, well I would wager that we've done that. A1 for substitution. The substitution of v y on x for v, so we did that. And A1 for solving for y, so we did that as well. So we get our 4 marks there, and then we also got c equals minus 2. And I'll leave it there. There is a part B, but we'll do that in class.